Hi, I'm Lanita Fix, the Executive Director of the Reef Institute. I'm here today to talk to you about my favorite animal, coral, how climate change is affecting it, and what we in Florida can do to help. While coral reefs take up less than 1% of space in the ocean, over 25% of all marine life rely on reefs directly for their habitat. Reefs help produce the world's oxygen. Hundreds of millions of people rely on reefs directly for their livelihood. Billions of dollars of Florida's economy alone rely on reefs. But the most selfish statistic I like to point out is that according to a Stanford University report, 97% of all wave energy is first absorbed by coral reefs. They're our first line of defense when those waves from hurricanes come. To really care about coral, we first need to understand it a little bit better. So, coral is an animal in the same family as jellyfish and anemones. You can think of it as the jellyfish has been turned upside down and its little tentacles are hanging in the air. One individual coral animal is called a polyp. So when you look at this photo here, each purple polka dot with the green center is its own animal. Each animal that you see here has its own ability to reproduce, eat, and protect itself. The coral animal lives in a symbiotic relationship with a type of algae called zooxanthellae. So you can actually see the zooxanthellae here. Coral animals are actually clear and their skeletal structure is white, but it's that algae that gives the coral its beautiful color. It's photosynthetic, producing oxygen and taking in carbon dioxide. It's also what gives coral most of its nutrients. So while the animal can feed itself, most of its nutrients are coming from that symbiotic relationship. And the animal actually eats copepods out of the water column. So once coral wants to grow and become older, unlike other animals, instead of looking older, it begins to multiply. More polyps begin to form and it becomes a colony. It isn't until you have multiple different types of corals living together that you actually are able to form a reef. Coral falls into primarily two categories: stony corals, that are our reef building corals, and soft corals, which are our sea fans. So your sea fans, your sea whips, they have just enough skeletal structure to be able to hold them up, and they create biodiversity, but they aren't creating the structure of the reef. So when we discuss our reefs really being in trouble, what we're talking about are these reef building corals. So what is happening to our reefs across Florida? Chances are, if you're a diver or a snorkeler, you've been out to the reef and you think to yourself, there's something not right. So what's wrong? Human impact, climate change, warming sea temperatures, ocean acidification have all kind of caused this soup that's causing our oceans to go a little bit crazy and affect our corals. Issues like disease, coral bleaching are making the news more than ever before. A particular disease called Stony coral tissue loss disease was actually first detected off the coast of Miami in 2014. Now, it's not the first disease that corals have ever gotten. What is devastating and interesting about this disease is Florida only has about 43 to 46 reef building species, and over half of these are affected by this disease. It has an extremely high mortality rate. Once it enters into one coral polyp, an entire colony can be gone in days or just a couple of months. Corals that are hundreds of years old can be gone really, really fast. I think the most interesting thing about this disease, other than its devastation and its high mortality rate, is that we're almost 10 years into the discovery of this disease, it is affecting the entirety of the Florida reef tract and across the Caribbean, and all we know about it to date is that it's waterborne. Looking at this reef once again, if you see some of the blotchy spots, that's actually disease taking out this reef. This summer, coral bleaching made the news quite a bit. So here's what happens when corals bleach. A healthy coral begins to be stressed. That zooxanthellae algae begins to overproduce oxygen, and the animal makes a choice to expel that algae. It's called bleaching because now the animal begins to pale. If you remember, I said the animal itself is clear and you can see through to the skeletal structure. It's literally getting rid of this thing that gives it nutrient because it thinks it's causing it stress. And so now the animal begins to starve to death. There are instances, and we're going to talk about this later, where highly adaptable coral can actually take in a better type of zooxanthellae that can survive bleaching. But what happened this summer is that the ocean got too hot too soon, and corals that were not used to adapting were not able to keep up with these ocean temperatures. And so they began to die. This is one of my favorite pieces of footage to show kind of what's going on with our reefs and really the devastation that we see. It looks all brown, and if you look really, really closely, all you can see are some of those soft corals, but there isn't a lot of structure, and there isn't a lot of life either. But you come around because it has been devastated, and everything is literally living on this one coral head. It shows you the importance of living coral. So, due to these issues, this bleaching, this disease, we are now left with only 2% of our coral coverage in the state of Florida. This pillar coral that you see here is functionally extinct in the wild. It may seem like the situation is lost, like everything is dire, and the ocean has just gone crazy, that this foundational species is lost for good. However, I'm here to tell you that there is hope. There are organizations across the Caribbean, across the state of Florida, that are actively working together to solve the issue. While we may not be able to solve everything that's causing the issues in the ocean, climate change, the human impact, what we can do is create solutions that move from coral conservation to full coral restoration. The first way that we can begin this restoration process is by rescuing corals and bringing them to land. This first began in 2016 by Florida Fish and Wildlife Commission in conjunction with NOAA and eventually with Department of Environmental Protection to create land-based holding where we can protect these corals from disease, we can preserve the genetics, and we can create all of the parameters that should be happening in the ocean safe on land. The genetics can be kept and these corals can be reproduced and their babies eventually going back out into the ocean. So corals that are functionally extinct in the wild can be kept safe under the watchful eye of aquarists and experts to be able to keep a rescue mentality. This summer, when those coral bleaching events started happening and we had the hottest ocean temperatures that we have ever had in the Florida Keys, we knew in Florida that we needed to do something. So we began to bring some of these corals to land for safekeeping. So the same idea of rescuing them from the water and bringing them onto land, and the Reef Institute became one of only 2 organizations that would be able to hold those corals for long term. So after we've held the corals and we've rescued the corals, the next idea is let's see what we can do to reproduce them. So corals can reproduce both asexually and sexually. So asexually, you can take a large coral and break it into smaller pieces, and then it can become smaller pieces of coral, and that can be used for restoration. The problem with that is that it creates clones. So in addition to that asexual reproduction, we also have to work in sexual reproduction. Using technology, using lights and mimicking the moon and ocean temperatures, corals can be reproduced on land. Those little bundles that you see releasing into the water column are actually sperm and egg that will go to the surface of the water to find each other, be able to fertilize, and then actually become juvenile corals. The only time coral moves in its entire life is in the first couple of days of life. You can see it goes to the surface of the water. It will eventually begin to float across the water column and then will eventually swim down to find its forever home. It's really amazing that we are able to actually create all of the parameters on land that you would find in the ocean to allow for coral reproduction. This allows for us to be able to take an active restoration mentality towards this animal in a way that can produce thousands upon thousands of animals. Now, mind you, only a couple of organizations have actually been able to see this reproduction happen at this time. You can see that we collect the larvae, and as you look in these tanks, you're about to see what look like little pieces of dandruff. Those are actually coral larvae getting ready to swim down to their forever home. And once they land under the microscope, they immediately look like a coral colony. As these corals are able to be taken care of and grown, eventually, after a couple of years, they actually will become large enough to be able to be used for something called outplanting. This is when corals become large enough that we are able to attempt to put these juveniles either asexually or sexually reproduced back out in the wild. So you may have heard about this concept of outplanting. So the ability to outplant from corals that have been grown on land to going back out into the ocean is a relatively new idea in the state of Florida and is still considered sort of in the pilot phase in a lot of ways. In the past, corals have been kept on coral trees under the ocean or in other mechanisms in ocean-bound nurseries to be able to go back out. But these corals were actually grown on land at the Reef Institute, and they are being used for restoration primarily in Palm Beach County, but also in other spots across Florida. This gives us the ability in Florida to actively restore our 360-ish miles of reef, even though it's in a dire space. And the really cool thing about these juvenile corals is that they're proving to be more adaptable. So we take the coral, it's on a small tile, and then using a small piece of epoxy, we actually place that piece of coral back down on the reef where it's going to be able to grow. And the hope will be that these sexually reproduced corals will create not just biodiversity from the perspective of different types of corals around, but will actually create reproducible corals that will be able to, not just in a lab, but continue to reproduce and restore the ocean on their own. They're intentionally placed in a certain position away from each other in sites that are picked by local government or state government, and then they are put down so that we can keep track of them. So what we do at the Reef Institute is we actually go out and check on our coral babies once a month. And we've seen this summer that they have been able to avoid predation. You saw our little triggerfish that was bothering us before, and they're actually also surviving warming sea temperatures. So these corals are proving to be quite resilient. And I understand when we use words like outplanting why we think of coral as a plant, but it is an animal that reproduces like other animals. And as it takes its structure on the reef, will continue to reproduce like other animals and keep growing. Scaling up efforts like outplanting give us the ability to directly restore our reef. The wonderful thing about these innovative practices is that we can innovate across the Caribbean to be able to reproduce these same scaling and restoration efforts. In Turks and Caicos, for example, you can see they're modeling land-based holding in the same way that we're doing things at the Reef Institute, educating the public and being able to bring in local stakeholders to help them to take ownership of their own backyard. Sometimes the reef might just need a little bit of extra help. And that's where the Marine Living Structures Initiative comes in. It is made out of 70% recycled material. So Portland cement can create some of the largest carbon footprint in the world, and this innovative project actually reduces the carbon footprint by 50% while creating a material that has the same strength as cement. If our reefs are in this dire place, while putting out the babies is one step, we might need to build some extra structure. And this structure was actually recruited to be modular so that coral might come back and recruit on this structure in the future. Goal is to create connector reefs in smaller units or larger units that can help with that wave break, and to create a material and a structure that is a gray-green space that eventually mimics the reef and is overtaken by coral at large. We must rescue, we must restore, we must outplant, but we also must research. Nearshore reefs in locations like in the Lake Worth Lagoon in Palm Beach County and off the coast of Miami are proving to be quite resilient and adaptable. The corals that you see here in these photos actually have been researched over the last 4 years by the Reef Institute. And while they do bleach every summer, we are working with the University of Miami to actually prove that they can swap out the type of zooxanthellae. So different zooxanthellaes actually are showing to be more adaptable to different heat stressors or different stressors in the ocean. And we're actually looking at these corals to prove that while they do pale in the summer, they come back every year. So after 4 years of research, our scientists have seen that every summer they pale, going almost white like you see here, and then actually around October and November we begin to see that color return and the resilience of these corals to be able to return. Researching corals like this that are in these hot zones that are facing all sorts of issues and adaptations, changing salinity, changing ocean temperature, and extreme human impact, prove to us that corals, while they can be the divas of the sea, can change. They can become resilient if given the opportunity. Research like this actually shows the resilience of coral and the proof that in certain situations it actually can survive if it's given the chance. The hope would be to be able to study these corals, learn from them, and see just the biodiversity and the ability that they can give to coral at large to be able to create a better future. Let's revisit some of the footage that we looked at when we first started our time together. We might look at coral a little bit differently now. It's delicate, it's in trouble, but there is a glimmer of hope. I've been asked, is it worth it? Should we try? But I hope that you look at this creature a little bit differently, and I hope you know that working together, we can do something about it. We can change the way that we look at the ocean. We can change the way that we treat the water as we get into it. We can make the choices that we need to make to lower our pollution and keep the ocean a little bit freer of disease. The pillar coral that you see here is still alive in the ocean. All hope is not lost. And at the Reef Institute, we are actively working to save our reefs. I'd like to end my time with you today by giving you an overview of what we are doing at the Reef Institute to save our seas. Welcome to the Reef Institute, Palm Beach County's only coral conservation center. We are on a mission of coral conservation through education, research, and restoration. We take a full circle approach from rescue to reef. Our focus is to educate, rescue, conserve, restore, and innovate. It all begins and ends with education. We take an awareness to stewardship approach. This involves programming in and outside of the classroom for all ages. We build from awareness of coral conservation to better stewards of the ocean at large. We are proud to be a land-based coral nursery, one of many organizations collaborating in the Florida Coral Rescue and Propagation Project. We are given the honor of holding rescued corals in our facility here in West Palm Beach, Florida. Our coral nursery is raising thousands of babies. With our technology and staff, we provide everyday essential care from feeding to cleaning. When the corals are old enough and ready for their big day, we head out to the ocean. We delicately place them in secure locations off the coast where we can monitor their progress. Currently, we're working in the Lake Worth Lagoon to monitor and care for corals that are right in our own backyard. The Reef Institute specializes in partnering with organizations throughout the Caribbean. Our efforts start within the community and end with locals taking ownership of coral conservation. We also innovate through the Marine Living Structures Initiative. These ecologically engineered modular reef systems are designed in partnership with Michael Singer Studios. It's with the efforts of our unique staff of aquarists, scientists, interns, and experts that we are able to accomplish our mission. Problems in the ocean are huge, issues with coral are massive, and we need your help to fix it. Join us in the journey by visiting our website at www.reefinstitute.org, where you can find more information about our educational programming, donating, or ways to get involved. The Reef Institute. We save the ocean. Thank you so much for your time today. I hope that you really do believe that together we can save the ocean. Get out there, do something, make a change, and we can make this better. You have time, talents, and treasure that you can give. Please get involved.